Bismillahirrahmanirrahim. Welcome to the sequential control part 6. The question is today perform continuous operation a plus b plus c plus a minus b minus c minus. So it will happen repeatedly. So after c minus, again a plus, b plus, c plus, and so on will happen. So for this video, I want to refer to the previous video part 2, and you have to watch that because I am going to use the circuit in that video. So this was the circuit I solved in the part 2 video. I already explained you how this circuit works, but don't worry, I will explain very clearly in this video too. I have A and B cylinder. I also need another cylinder which is C. So I will copy this. I will remove the identification and I will draw them during explanation. Okay, so let's start. So I already explained you this part. This is for the operator to control. I gave the operator the freedom to initialization and termination of this whole sequence. So when the operator pushes the on button, the sequence continues. It will go into a loop and it will stop if the operator pushes this off button. So okay, let's see how this works. So when operator pushes this on button, okay, this side will get activated, signal will go through here. This pneumatically controlled 3x2 DCV left side will get actuated. Okay, flow will go through here, but I also need to activate this lever plunger. So how can I do that? You see before A plus, what is happening? Before A plus, C minus is happening. So the identification will be C0. I hope this is clear to you because at the initial position, cylinder C is already retracted or in the C0 position. So C0 will get activated and here this flow will get to the left side. So two conditions are fulfilled. And one thing I want to mention is that this pneumatically controlled 3x2 DCV is like a memory valve. So when a signal goes here in the left side, it will remain in the left side unless someone gives signal to the right. We saw that this condition and this condition is fulfilled. Signal will go through here, flow will continue to flow. Left side will get activated, flow will go here and A1 occurs. After occurring A1, I need B1 to happen. This lever plunger will sense A1. So flow will go here and here. B1 will get activated. After B1, I need C1. So this lever plunger will sense B1. After sensing B1, this side actuates, flow go here. Left side of this 5x2 actuates, flow go here. Cylinder C extends, C1 occurs. Right. After occurring C1, I need A0 to happen. This lever plunger will sense C1. When it senses C1, flow will go here, activates this, and A0 achieved. After achieving A0, I need B0 to happen. So this lever plunger will sense A0. Flow goes here, and B0 occurs. After happening B0, I need C0 to happen. So this lever plunger will sense B0. Flow goes here, through here, and C0 occurs. After C0, I need A1 to happen. Continuing the loop, so C0 is already sensed by this lever plunger and flow is already here. So both condition is met and this flow continues to flow and the cycle continues. So this is the overall solution, and when operator pushes this off button, signal will go through here. The right side of this 3x2 DCV activates and we can see there is no flow. No compressor is giving power to this 3x2 DCV. So that's all. And if you want to see the step diagram and timing diagram, this is same as the previous, very simple. Now let me show you the simulation. Okay, so this is the circuit. I exactly did what I explained. So let's start the simulation. When I press the on switch, watch carefully what happens. Now pressing the off switch. See, let me show you again. Pressing the on switch, pressing the off switch. So you see A plus B plus C plus and A minus B minus C minus happened in a loop. And when I press the off switch, it goes back in the initial position. So that's all. If you have any confusion, please feel free to write in the comment.